You guys are ready. Can you explain what you built?
Okay. So can I start now?
Uh-huh.
Okay. So hello everyone. I'm Junze Zhou. This is my teammate Yibin Xu, and this is my teammate Shih-ming Lin. And for our project, we have implemented a simple accelerator for the convolutional operations. And here we use three different scenarios to demonstrate the functionality of our accelerators. So first, I will demonstrate the first application that we use. So firstly, okay, wait. Okay. So specifically, we have implemented a simple and a small neural networks with the input channel of 16, and the output channel is only two output channels with 14 by 14 feature maps,
okay.
And the original feature map is 13 by 13. Yep.
So here we're gonna have the original graph showing.
Okay.
And those two gonna be like the two output feature map here.
Sure.
And
yes. Okay, so these two feature maps is two of the 16 original input feature map.
Okay.
And the other 14 input channel of this input group is always 0.
Okay.
It's convenient for us to demonstrate. And this one is the output channel. It's one of the output channel, and this one is the other output channel, because we only have two output channel with 14 by 14.
Sure. Okay.
Oh, and this one is the immediate results. So it's also 28 by 28. You can see it's similar to the original size.
So the input channel is 30 by 30, and then these two reach 28 by 28?
Yeah.
Is that right? Okay.
Okay, and we also added a threshold to make animations.
Uh-huh.
It's
Oh, you have.
okay. It still work.
Okay, so never mind. So okay, so basically this threshold is to control the what can I say about that?
I control the input of the threshold, and so that we can easy to determine which threshold is the best for demo this Tai Chi image. So
it's basically like the highest threshold we get, the more white space we got, and the clearer the edge gonna be showing.
Okay.
Yeah. So basically, it's the first scenarios, and then we'll demonstrate the second scenarios.
we can reload this.
Okay.
Yeah.
Okay.
So okay, so as you can see that this the first channel, the left channel is the same as the previous shown, and the right channel is what we use a different weight apply on the or different kernel apply on the original input. So and this kernel is work for age detection, and as you can see, it highlights the two input channels age as the white and black, the age between the white and black. Yeah.
Like for this one, we can have different feature map as we want. We only demonstrate two here, but we can definitely go more. We can go 8, 18, 18, or depends on what you need for the output channel.
Yeah, and overall, each output channel will represent specific features of the original feature maps.
Cool.
Can I go grab the cable?
And this one is the one we do the pooling.
Yeah.
This
Okay.
one is-
So basically, pooling operation is kind of important operations in the convolutional layers, and for the previous two scenarios, we have demonstrated the convolutional layers without pooling layers. So here we demonstrate the convolutional layer with the pooling layers. So the pooling layers will decrease the size of the input feature maps. So if I use the pooling layers with a stride of 2, you can see that the output feature maps will be, the size of the output feature map will be the half of the original one. Yeah.
So when you say pull, you're combining group 2 by 2
Yeah.
grids of
Yeah. So if you can
pixels.
see here, this is the convolutional operation, and this is the pooling layers.
Okay.
So like, I think this one gonna be better to show. So what we have here, like our processor, our FPGA was capable of taking 8 channels at each time, and so it was able to take 8 channels like at the same time. And then if you want to do 16 channel or 24 channel, as long as it is multiplied of 8 or any channel size you want, you're gonna just repeat the loop and to like have more channel input. So let's say if you have 64-bit of 12 channel input, and sorry, not 12, 16, 16, and we have 8 here, and then we do the we times the weight, and then we got the result, and we wrote the data into the corresponding pixel on the output side, and then we are not output the data yet. We're gonna go back and do another 8 channel and have the data written at the same pixel here. And once all the pixel was being written into the output feature map, once all the pixel was being written into the output feature map, and then we're just gonna do the once all the pixel into the output feature map, and we're gonna combine those feature map into like just one, because let's say I have 16 channels and I should get 16 picture, and then I'm gonna combine the 16 picture together into one output frame.
Yeah, and this one output frame is one of the features of the original pixel. Yeah.
Cool.
And here is the data flow chart that we have, and we're gonna have the ARM sending the data to the FPGA. That's the entire part is the FPGA. We have the ARM sent to the input frame buffer, and then go to the line buffer because it's in data stream, and we have the weight buffer here, and then the weight buffer times the input frame buffer. We got the result and do the convolution, and then go to the adder tree, like we combine all different channels together, and then we have all the data stored inside the ACC buffer because we have multiple channels. So once we finish calculating all the channels, we're gonna do quantization, and then for the quantization, for pooling, we still need to use another 2x2 line buffer to do the pooling, and then depends, like here is the max, like depends if we want to do the pooling or we just go directly to the buffer output back to the ARM.
Okay. Very nice. Cool. Thank you guys.